Hi future doctors, welcome to the next class. We discussed time period of a magnet in uniform magnetic field. So we got that equation T is equal to 2 pi root I by mb. So I is moment of inertia, m is magnetic dipole moment, b is magnetic field intensity. Same like this in electric field, if you place dipole, so we didn't discuss this there. So if it is separated by 2a length in place of electric field, uniform electric field. Now, what is the time period of this dipole? Electric dipole means same. P is equal to 2 pi root I by, in place of magnetic moment, what we will write here? P, dipole moment. In place of electric field, we will write E. Okay. So here I is magnetic moment means, sorry, moment of inertia of small bar magnet, that is m a square by 12 plus b square by 12. So whenever this breadth is neglected, we wrote nearly this is m a square by 12. Now what is the moment of inertia of this one here? From here it is at distance a. So from center it is at a distance a. Therefore, charge of mass particle is small m. Charge of negative mass particle is small m. Mass cannot be negative. Therefore, what is the moment of inertia means m into a square. In rotational dynamics you will get m into a square. Therefore, 2m a square. If you write here 2m a square. This m is mass, not pole strength. This is dipole we are writing in this pole strength, that is. Divided by, what is dipole moment equation? Q into 2a. So therefore, Q into 2a E. So whenever we are solving the problem, they are going to write like this. This a square, a will be cancelled. This 2 will be cancelled. 2 pi root ma by. So Q into E sometimes. Where small m is mass of this, one of the charge, a is O2, one of the charge, center to one of the charge distance. So try to remember this formula. Once you remember this, moment of inertia E equal to 2m a square. Dipole moment already you can remember. If they ask a problem means you will solve very easier. Next we will see relation between B, H and I. Very important and confusing relations these are. So what is capital B? Capital B means we came to know magnetic field. Magnetic field or magnetic field intensity or magnetic flux density. Okay, I is intensity of magnetization. Intensity of magnetization. So H we will call generally magnetizing field. Intensity of magnetizing field or magnetizing field. So what is magnetizing field means? The magnetic field which is making a magnetic material into magnet. A magnetic material can be converted into magnet. Magnetic material can be converted into magnet. So if magnet only converting north pole, south pole. So this is magnet. Around this what will be there? Magnetic field will be there. So this magnetic field is converting one magnet. One magnet means, sorry, one magnetic material. Magnetic material means, so all these dipole moments will be there in one particular directions. So this magnetic material will become as a magnet when all these magnetic moments aligned in one particular direction. So if it is disturbance is there, then it is magnetic material. If all are aligned in one particular direction, that is magnet. Who is making this magnetic material as a magnet means some magnetic field. So which magnetic field is making magnetic material as a magnet? This magnetic field we can call it as magnetizing field. Okay. So sometimes B will be calling magnetizing field also, depending on what it is going to do. So around this magnet B is there. This B we will call generally magnetic field. If that magnetic field is converting a magnetic material into magnet, then that is called magnetizing field we will call. So for example, if you are taking a magnet, one iron needle if you place, here iron needle if you place. So if you remove this magnet, now this iron needle will attract another small iron needle, because so presently sometime this iron needle will be acting as a temporary magnet. So why this iron needle acting as a temporary magnet means, because this one they kept in contact sometime for magnet. Now this iron needle became magnet only for some time because of this magnet. Now this B we can call magnetizing field for this iron. This B is called magnetic field for this magnet. So generally we will take in solenoid. Solenoid is nothing but a hollow cylinder is going to be wound by one wire. If we are sending some amount of current I in this, so every current carrying conductor will be producing magnetic field. So therefore, it is going to produce some amount of magnetic field at center. So this magnetic field at center of solenoid formula generally we will write like this. B is equal to mu naught Ni. What is small n here? Number of turns per unit length of the solenoid. Sometimes we are taking solenoid length is this much only. So on this much, number of turns will be less. On this, number of turns will be more. Therefore, so the small n we are calling it as number of turns per unit length. So in terms of number of turns per unit length, n by L into, this is in terms of number of turns, this is in terms of number of turns per unit length. Both are not same. Capital N is nothing but number of turns, small n is nothing but number of turns per unit length. So if it is cylinder means, so hollow cylinder means, if you are taking wire like this, if you are taking wire like this, it will be going like this. So it will be going means, so it will be going backside. So like this, if you wound wire, after going at the end, it will be going backside. If you are starting from here, it will be ending backside of this cylinder. So if you are starting here like this, then it will be ending here. Therefore, if it is going like this means anti-clockwise. Anti-clockwise means this one will be acting as which pole? Anti-clockwise means north pole. So here it should come definitely clockwise. That will be south pole. So this solenoid is producing magnetic field. Its direction is from south to north inside. So for that we are calling this Ni. So B is equal to mu naught Ni. So this Ni only we will be writing it as mu naught H. H is nothing but magnetizing field. So when magnetizing field we are calling it as means, if you place any magnetic material inside this hollow cylinder, this magnetic material will become as a magnet because of this magnetizing field. So already one magnetic field is there. Now if you place one magnetic material inside the solenoid, that magnetic material is going to become magnet means this H we are calling it as magnetizing field. Therefore, magnetizing field how much means Ni. If you use this formula, you are going to get the answer. This is the H. Now, how we are going to get relation between B and H means B is going to be mu naught H if it is permeability of free space. If it is medium means B is equal to mu H. Relative permeability, mu R is equal to mu by mu naught. So already we came to know this one as epsilon R equal to epsilon by epsilon R. Like that, relative permeability is mu by mu naught. In place of mu, we will write B is equal to mu naught into mu R H. So this is B and H relation. Now we will see intensity of magnetization. When this term will be used means how much intensity it is there to convert a magnetic material into magnet. That definition also we will give now. Now see, if you are taking a magnetic material, this is magnetic material. In this, all these dipoles are there in their one particular direction. We are taking one magnet. This is single touch method they are going to say. So this magnet I am bringing like this. Continuously I am bringing like this. At the time, some of these dipoles are going to be aligned like this. only in this portion. So remaining as it is like this. So still if you are doing, again some are going to be aligned in one particular direction like that. So all these magnetic moments within this volume, magnetic moments aligned in unit volume is nothing but intensity of magnetization we will call. So like that, if you are doing more number of times, all magnetic moments aligned in one particular direction, then this one we are calling it as south to north magnetic moments direction will be. Now this one we can call it as magnet. This one we cannot call magnet. This is magnetic material. So magnetic moment per unit volume. This is called intensity of. So only less number of magnetic moments aligned, more number of magnetic moments aligned. If all volume is going to be aligned, magnetic moments means intensity is going to become more. I is equal to m by v. So what is the magnetic moment definition for us? M into 2a or 2l. Volume of this one is area into length. That is 2a. I am taking length. Therefore, if you cancel this, so pole strength per unit area, pole strength per area or magnetic moment per unit volume. So you can write units also. Magnetic moment units ampere, meter square, volume units meter cube. Therefore, ampere per meter is the intensity of magnetization. Next, magnetic susceptibility. Magnetic susceptibility, Xim. So it is going to be defined as I by H, ratio of intensity of magnetization to magnetizing field. So relation between relative permeability, mu r is equal to 1 plus Im they are going to write. This susceptibility is going to define how much intensity we are going to get after magnetization. How it is defined means if Im value is more, we can convert that magnetic material into magnet. Best example, ferromagnetic material. Ferromagnetic material can be converted very easily into magnet because psi value is going to be more. And this psi value of magnetic susceptibility will be depending for dia, para, ferro. How it is going to be depending means for diamagnetic material, Im value negative. It does not depend on temperature. For paramagnetic material, psi value little bit positive. So Xim is inversely proportional to temperature, absolute temperature. That is nothing but Curie's temperature means Curie's law we will call ferromagnetic material. Up to some temperature, it will not depend, but so still if you are raising the temperature at particular temperature, ferromagnetic material will become paramagnetic material. That temperature we are calling it as Curie's temperature. Above Curie's temperature, so susceptibility is inversely proportional to absolute temperature they are going to call. So the theoretical diapara-ferro differences I am not giving. So I am giving only these equations how we are going to be applied for number of given problems easily. Okay. So try to understand. So a little bit confusion will be there for these names. So without confusion, you people should remember. So B is equal to mu naught H. So B is equal to mu H. This is in medium. This is a free space. Where H is going to be, we are writing it as Ni. Okay. I hope you people understood. Thank you.